Hi guys, so here is a question from GATE 2019. Find the value of current I in the given circuit. So the circuit they have given and it is very simple only. So the straightforward way to solve it is you can assume this node voltage as some V dash and you can write the KCL equation and you can find V dash and then I will be given by V dash by 20 ohm. So another way to do it is using superposition where you can only consider one of the voltage sources at a time and find the current I and finally sum them up. So third way will be your source transformation. This is a voltage source and resistor. You can convert it into a current source and a parallel resistor. So that way the circuit will be simplified and you can directly find the current I. So fourth way is you directly find the Thevenin equivalent of this part of the network and then find the current I. So here the first straightforward method and the source transformation method I think is simple and quick to solve. So let us go with the straightforward method itself. Okay. Okay, we have this. So we need to write the KCL on this node V dash. Okay. So it is 200 minus V dash by 50 plus 160 minus V dash by 40 plus, and here since it is inverted it will be minus, right? So minus 120 minus V dash by 30 plus here again it is minus 80. Minus 80 minus V dash by 20 and this is equal to V dash by 20 ohm, the last arm. So this if you simplify and take V dash to the other side, what you will get? So you'll have 200 by 50 plus 160 by 40 minus 120 by 30 minus 80 by 20 is equal to V dash into 1 by 50 plus 1 by 40 plus 1 by 30 plus 1 by 20 plus 1 by 20. So to save time while writing KCL, we can actually ignore this step and directly write this step only. Let's see how. So if you're writing KCL on this node, so you consider V dash and you see how many resistors are connected to that. So all those resistors you write it as V dashes constant term, right? So it is 1 by 50 plus 1 by 40 plus 1 by 30 plus 1 by 20 plus 1 by 20. And on the other side, you see where all these resistors are connected to. So you write that node. So this 50 ohm is connected to 200. So 200 by 50 plus 40 ohm is connected to 160. So 160 by 40 plus here it is minus 120 by 30. Minus 120 by 30 and minus 80 by 20, and here it is 0 by 20, which is nothing but 0 itself. So this term we needn't write. And if you observe, this is nothing but what we got already. So by writing it in this way, we actually saved a step and hence we can save time. Okay, so now we have to simplify this. So the right hand side, it is easy. So this is 4 times, 4 times, 4 times, this is also 4 times. So what it is 4 plus 4 minus 4 minus 4. So this is straight away 0. So whatever this term was into some g, right? And as long as g is finite, your v bar is going to be equal to 0. Your v dash is 0. So if your v dash is 0, what is your I? Your I is nothing but v dash by 20. So this is also going to be equal to 0. So your answer is 0. So this is one method. Let us also quickly see what happens in our source transformation method. So in source transformation, what we have? So any voltage source in series with some R, this can be transformed into a current source of value I equal to V by R with a parallel resistor, right? This value is R only. So each of these arms can be transformed into a current source and a parallel R. So let us do that. So 200 by 50 is 200 by 50 is 4. It will come in parallel with 50 ohm. And next 160 by 40 is 4 again. So it will come in parallel with 30 ohm. Again, here it is minus 120 by 30. So it is minus 4. Or you can write 4 and invert the arrow. And this was 40, right? So here it is 30. Similarly, minus 80 by 20 is minus 4. And this is 20. And this is again 20. So now you can combine all these current sources. Since they are in parallel, they are going to add up. So I'll put one current source whose value is 4 plus 4 minus 4 minus 4 equal to 0 ampere. Then all these 50, 40, 30, 20 are in parallel, right? Some effective, let's say R equivalent. And then we have this 20 ohm and we need to find this I. So if you observe, any I flowing through this should be coming from this guy, right? Because this R equivalent is a passive network. Or you can also say your I is nothing but whatever this I dash, right? I dash into this R division. So it is R equivalent by R equivalent plus 20. So now this I dash itself is 0. So this I will anyway be 0. So we arrived at the same answer. So this answer is 0 ampere.